This video is about operations on rational numbers. So first of all, what is a rational number? A rational number is a number that can be expressed as a fraction, like a over b, where both a and b are integers or whole numbers, and b is not zero, because you cannot divide by zero. And what are whole numbers or integers? So we denote the set of all whole numbers by z. This is the set that contains 0, plus minus 1, plus minus 2, plus minus 3, and so on. So all these numbers are whole numbers or integers, and a rational number is a number that can be expressed as a over b, where both a and b are integers, members of this set, and b is not zero. Notice that with a rational number we have a fraction line, and we have one number, one integer on top and one at the bottom. The one on top is the numerator and the one in the bottom is the denominator. So if I'm referring to the numerator, I mean this number on top, and when I say denominator, I'm referring to this number at the bottom. Now let's look at some examples of rational numbers. For example, 2 over 3 is a rational number. Minus 5 over 7 is a rational number. 0.3 is a rational number because I can express that as 3 over 10. All whole numbers are rational numbers. For example, 5 is a rational number because I can express that as 5 over 1. Negative 3 is a rational number because I can express that as negative 3 over 1. Now, how do we multiply these numbers? Assume that a over b is a rational number, and you want to multiply that by c over d, which is another rational number. In order to multiply two rational numbers, the only thing you need to do is to multiply the two numerators. So a and c, you multiply them and they go into they form the numerator of the product, and you multiply the two denominators, b and d, and they form the denominator of the product. Let's look at some examples. 2 over 3 times negative 1 over 5. So I'm multiplying the numerators. 2 times negative 1 gives me negative 2, and 3 times 5 gives me 15, and that's the answer. Another example. Negative 8 over 10 times 5 over 4. So you can do negative 8 times 5, negative 40, and 10 times 4, 40. Negative 40 over 40 is negative 40 divided by 40. That gives me negative 1. There's another way I could do this multiplication. I could do this. Negative 8 over 10 times 5 over 4. I could write negative 8 as negative 2 times 4. And I could write 10 as 2 times 5 times 5 over 4. Now, here this 5 in the numerator cancels this 5 in the denominator. I'm replacing them with 1. And this 4 in the denominator cancels this 4 in the numerator. And this 2 in the denominator cancels this 2 in the numerator. So as you can see, I'm only left with one negative. That gives me negative 1, same answer. So another example, 6 over 25 times 15 over 9. So for this one I can do 2 times 3, that's 6, 5 times 5, that's 25, 3 times 5, that is 15, and 3 times 3, that is 9. Now 3 cancels 3, 3 cancels 3, 5 cancels 5, and I am left with 2 over 5, and that's my final answer. Okay, now let's see how we divide rational numbers. So again, assume that a over b is a rational number, and you want to divide that by c over d. So the way you do the division is that you convert your division into a multiplication, and that's the way you do that. So you keep the first fraction or the first rational number as it is, a over b. You convert the division into multiplication, and you inverse the second rational numbers. By inverse means you flip it. So d goes on top and c goes at the bottom. And then you can do the multiplication. So this is AD over BC. Okay, let's take a look at one example. Negative 5 over 8 divided by 7 over 3. So it's negative 5 over 8 times 3 over 7. This gives me negative 15 over 56. Okay. You can also express a division like this: a over b over c over d. This is just a division. This is a over b divided by c over d, which is a over b times d over c, which is ad over bc. So you could take a shortcut and just say that this is AD over BC. So you can memorize this as a formula, and the way I memorize it is that I say the two numbers that are farther away from each other, I multiply them and I write them on top as the numerator, and the two numbers that are closer to each other, I multiply them. So B and C, I multiply them and I write them as the denominator. So you can memorize this as a formula. Let's take a look at one example. 2 over 3 over negative 1 over 8. So this is the two numbers that are farther away from each other, 2 and 8. You multiply them, you get 16. And the two numbers that are closer, 3 and negative 1, you multiply them, you get negative 3. So the answer is negative, it is 16 over negative 3, which can also be expressed as negative 16 over 3 or negative 16 over 3. All these are the same numbers. Generally, if you have a negative, for example, negative a over b, it's the same as a over negative b, it's the same as negative a over b. So all these are equal rational numbers. Okay, now let's see how we add them up and do the subtractions. If you have rational numbers a over b and you want to add that to another rational number c over b. So in this case you see that the two rational numbers have a common denominator. In that case, the only thing you need to do is to add up the numerators. So it would be a plus c over the same denominator b. So the same thing for a subtraction. A over B minus C over B is A minus C over B. So you're just subtracting C from A and you use the same denominator, common denominator. So for example, if you have 5 over 7 plus 2 over 7, this is 5 plus 2 over 7, 7 over 7, which is 1. Or if you have negative 3 over 9 plus 1 over 9, you have to add up the negative 3 and 1. This gives you negative 2 over 9. Now, what if you do not have a common denominator? If you do not have a common denominator, you need to find the common denominator. So, for example, if you have 5 over 8 plus 2 over 4, you need to find the common denominator between the least common denominator between 8 and 4. The least common denominator is actually the smallest common multiple of these two numbers. In this case, you can see, for example, 8 is a multiple of 4. 2 times 4 is 8. So here, 8 is the least common denominator. So the first fraction, you don't need to change at all. It's just 5 over 8. You just carry that, plus instead of 2 over 4, you can write 4 over 8, because 2 over 4 equals 4 over 8. And here you have a common denominator, so 4 over 8. Now you can use the same denominator, 8, and you add up 5 and 4, it gives you 9 over 8. So another example, negative 2 over 15 plus 4 over 3. Here, the common denominator between 15 and 3 is 15, because 15 is also a multiple of 3. You know, 5 times 3 is 15. So again, negative 2 over 15, no change, plus, instead of 3, you're going to multiply 3 by 5, and it gives you 15. And you also multiply 4 by 5, gives you 20. So 4 over 3 is equal 20 over 15, but by expressing this rational number as 20 over 15, we have created a common denominator. So one way to know why 4 over 3 equals 20 over 15 is that I can multiply both 4 and 3 by 5, and this gives me 4 times 5, 20, 3 times 5, 15. So this is something that you can always do. Generally, if you have A over B equals A over C over B times C, A times C over B times C. So you can always multiply any rational numbers. You can always multiply the numerator and the denominator of any rational number by any non-zero value C. So this is exactly what I'm doing here. I multiplied both numerator and denominator of this fraction by 5. It gives me 20 over 15. So I replaced 4 over 3 by 20 over 15, which has exactly same value. I'm not changing the value of this fraction, but now I have a common denominator. So now I'm going to use the common denominator and add up 20 and negative 2, which gives me 18 over 15. Now, I'm not actually done here. I can simplify this. So, you know that 18 is 6 times 3 and 5 is 5 times 3. So the 3 cancels the 3, so the final answer is 6 over 5. Okay, another example. Let's say 5 over 6 minus 7 over 5. So here, as you can see, 6 is not a multiple of 5, 5 is not a multiple of 6. The common denominator here is the product of 5 and 6, which is 30. So I'm going to draw a fraction line minus another fraction line. So 60, instead of 60 I'm going to write 30. Instead of 5 I'm going to write 30. Now, what did I do to this fraction? I multiplied the denominator by 5 to get 30. I need to do the same for the numerator. I multiply the numerator by 5 and I get 25. 5 times 5, 25. Notice that I'm using this formula here. I'm multiplying both numerator and denominator of the fractions by the same non-zero value c. So I multiplied 6 by 5 to get 30. I do the same for the numerator. I multiply that by 5 to get 25. Now, for this other fraction, this negative here, I just carried that. And then for this other fraction, I multiplied the denominator by 6 to get this 30 here. I do the same thing for the numerator. I have to multiply the numerator by 6, and 7 times 6 is 42, and then I just subtract 25 from 42, which gives me, okay, let me do that here. I do 42 minus 25, 12, 5 minus 12, 7, 2 minus 3, 1. So 42 minus 25 is 17. This means that 25 minus 42 is negative 17. Okay, and that's it.